Hello, ladies and gentlemen. Welcome to the course Signal and System Analysis. My name is Mavratu Alo at the Asosa University Engineering College, Department of Electrical and Computer Engineering. I got my MSc degree from Hawassa University in Control and Instrumentation Engineering in 2020. Currently, I am working as a lecturer in Asosa University. And also, I taught this course in this university for 2 consecutive years. So I hope we will have a good time while learning this course together. So I am your tutor for this course and this platform. So any questions are welcome via the live sessions that we will have together, as well as using another platforms. This course is your gateway to understanding how signals are represented, analyzed, and processed using powerful mathematical tools. So whether you are designing communication system, control system, power system, or digital signal processors, the concepts that you learn in this course are the mathematical of the things that we do together with these advanced systems. Therefore, what is the core vision of this course? The core vision or the vision of this course is by the end of this course, you will be able to analyze any signal or systems in both the time domain and frequency domain, design filters, apply transformators, and simulate real-world engineering systems using MATLAB as a software. So this is the general vision of this course. So the course syllabus. Let us see the course syllabus. First, the course information. In our university, in Asosa University, from Electrical and Computer Engineering Department. This course is found from this department, and its course code is EG 2121, and it is a compulsory, it's a mandatory course. So every undergraduate student has to take it. And its credit hour is 6 STS according to the current curriculum. And it's given from year 3, semester 1, contact hours, and there is a lecture, and there is a tutorial, and the students will have their own practice by simulating signals and systems by using MATLAB software. So to proceed to learn this course, the students should undertake first applied mathematics. This is a prerequisite for the signals and system analysis course. So on this course, calculus and linear algebra will be covered. So these concepts or these prerequisite knowledge are mandatory for the student to effectively take this course. So what does the course description look like? This course introduces students to the mathematical description of signals and systems, and the mathematical tools for analyzing and designing systems that operate on signals to achieve desired effects. So there are generally 6 topics that should be covered in this course. The first and the fundamental topic is classification of signals and systems. So before going to the advanced topics of this course, as an introduction, as an introduction part, the students should know classification of signals and systems. So what are the different classification of signals and the different classification of systems? So after being familiar, being aware of this classification of signals and systems, the second topic is how to represent signals by using different methods to simplify their analysis. So there are different methods to simplify to represent signals. So representation of signals, especially in the second topic, we will see 2 methods to represent signals, such as signal approximation using orthogonal functions and signal approximation using Fourier series. So Fourier series representation of signals and orthogonal function approximation of signals. So in more detail, the most important part in this topic is the Fourier series representation of signals. In the Fourier series representation of signals, there are two important Fourier series types that are used to represent any types of signals. These are trigonometric Fourier series representation and complex exponential Fourier series representations. These two things are very important for the proceeding sections as well as for the other more advanced courses. So you have to bear in mind, you have to focus on these two methods on representing signals. The other one is singularity of functions. What does singularity of functions mean? So this also covered in the second topic. So the third topic is time domain analysis of signals and systems. So how can we analyze systems and signals in their time domain form? So there are two approaches to analyze signals in time domain form. So first one is convolution method. And the second one is ordinary linear differential equations. So these two methods will be covered in the third topic. And the fourth topic is the Fourier transform, of signals and systems. So how can we obtain the Fourier transform of signals and signals and systems? What's the purpose of the Fourier transform? Why it is required to calculate the Fourier transform of signals and systems. Again, after finding the Fourier transform, it is necessary to convert back to its time domain after analyzing signals. So inverse Fourier transform is required. Another one is the frequency response of a system. So this is also covered in the first topic. And the fifth topic is the Laplace transform, which is very important on signals and system analysis. So in Laplace transform, we learn the Laplace transform and inverse Laplace transform, as well as the one important thing, system functions. And the last but not the least is Z transform, which is a discrete time counterpart of Laplace transform. Laplace transform is for continuous time systems, while Z transform is for discrete time systems. So in discrete time systems, similar to Laplace transform and Fourier transform, we will learn the Z transform and the inverse Z transform. So finally, we'll see the introduction about discrete time Fourier transform, which is dealt in detail in digital signal processing, which is the advanced course which we will take after the completion of this course. So this is what the course description looks like for this course. So the course objectives. So upon the completion of this course, you are expected to attain these course objectives. The first one is characterize, classify, and mathematically represent continuous time and discrete time signals and systems. The second one is decompose, predict signals into Fourier series and interpret frequency spectra. The third one, perform convolution and solve ordinary differential equations as applied to system analysis. The fourth, apply the Fourier transform to analyze signals in the frequency domain and understand the sampling theorem. The fifth, use the Laplace transform for system analysis, including pole zero analysis and stability. And finally, apply the Z transform to analyze discrete time systems and solve difference equations. So these are the course objectives that you will be able to attain, able to achieve after learning this course. This course is organized into 6 chapters. So each chapter contains weekly study guide, your roadmap for the week, lecture notes, detailed technical content of the course. So the lecture notes are incorporated for each chapters. So you will get lecture notes in description form in the platform as well as in downloadable document form. So interactive activities. and solved examples are also included. Discussion points for each chapter are also included, and quizzes, auto-graded quizzes. So you should focus on these quizzes and you should done well all the quizzes that are included in the course, and assignments are also included. So weekly schedule, chapter 1 are scheduled to be completed from the first up to third week. So it is introduction, signals and system classification. Chapter 2 is the fourth week. It will be covered in 1 week. Signal approximation and Fourier series. Chapter 3 in the fifth week. Time domain analysis, convolution and ordinary differential equations will be covered. Chapter 4, it is Fourier transform and sampling theorem. Chapter 5, Laplace transform and system analysis. Chapter 6, Z transform and discrete time systems. So assessment and grading system looks like this. Quizzes and tests are there in 16%, assignment in 10%, and final examination will be conducted in 13%. So finally, totally, at the end, we'll get 100% assessment. So these are the references, the recommended references. You can go through them as well as the PowerPoints and the notes created by scholars are also possible for as a reference. So thank you, students. This as an introduction for this course.